So for example, this is a triple assessment problem for 8 cities, right? So what we are being asked for 20 cities. The distances here are symmetric. So you go from A to B is the same as going from B to A. So what it means when the distances are symmetric is that you have a specific tour. So for example, if your tour originally goes in one direction, and let's say for now, let's say we only talk about 4, right? So you can have a tour that goes in one direction. You could also have another tour that goes in the opposite direction. Now, depending on whether or not the distances are symmetric or asymmetric, the total distance might be the same or different. So symmetric means that whatever distance you have here, going from A to B, will be the same as going from B to A. If the distances are the same, then for every part of the pair that are involved in this round-trip tour, all the distances are still the same. Which means that for any permutation of cities that you are considering, you can invert the permutation. Instead of going from left to right, you can go from right to left, and it will still be the same distance. Now, what it means is that given n cities, or in this case, like 20 cities, firstly, we want to generate the different number of tours. So the number of permutations is 20 factorial. That is not taking into account that it's a round-trip tour. But because it's a round trip, which means it's circular. So circular means that you can shift them one at a time. Regardless of the starting point, the same tour will still have the same distance. So this one, whether you start from A, and then you go to BCD back to A, or if you start from B, and then you have BCDA or CDAB, all these tours, regardless of the starting point, will still have the same distance. So in that case, we can divide this number of permutations by the number of times that you can shift the starting points. And there are 20 cities, so there are 20 different starting points. So you have 20 factorial divided by 20. Now this will result in 20 factorial divided by 20 is 19 factorial possible number of circular permutations. So this will be the case if it is not symmetric. So you have to generate all these 19 factorial possibilities. Now in the case that the distance is symmetric, which means that ABCD will be the same as DCBA, you can essentially divide it by 2. So you divide it by 2 because for any permutation, its mirror image will still have exactly the same distance. So for 1A, the answer is this one, which is the case when the distances are symmetric. And for 1B, the answer will be this one, when the distances are different. If the distances are different, we cannot simply take the mirror image because then it will not be the same. So now, the total number of tours will still be 20 factorial. But if you think about, for every tour, there are a lot of duplications in terms of the number of possibilities you need to examine. Because for brute force, you don't need to examine all the possible tours. If you examine ABCD, and the tour for DCBA is exactly the same, so then you don't need to compute it a second time. I think that's the key point here. All right? Okay, any clarification for question 1? So the number of possibilities you need to examine will be 20 factorial if it is a straight permutation. That is, if you are not returning. It means that you go from one starting point to the end point and you're not returning back, there will be 20 factorial. But if you are returning back to the starting point, then you need to divide by 20 because then we are counting the number of circles. If you're coming back to the starting point and at the same time you know that the distances are symmetric, then you need to divide by 2. Then this will give you the number of permutations you need to examine. Now, once you find what is the optimal answer, you can replicate the same answer essentially in 2n times. So for example, right, if we take this one, so I have this number of possibilities. Now, each of these tour I need to examine in order for me to get the best possible one. But suppose that I have gotten the best possible one, and it gives me a specific circular permutation. From that particular permutation, I can still generate many possible tours. So for example, once I find out that ABCD is the best one, then I can either go from A, so in that case I have ABCD, or I can go from B, or from C, or from D. Now, all these are equivalent distances. Now, because the distances are symmetric, I can go not just from A, B, C, D, but I can go in the other direction too, so which is D, C, B, A. In this case, I have A, D, C, B. In this case, I have B, A, D, C. In this case, I have C, B, A, D. So effectively, all these 8 tours will still give me the same distance. They're essentially the same tour, just from different starting points or from different directions. Okay, but the distances are exactly the same. Right?